1, 2, 3. 1, 2, 3. 1, 2, 3.
You know what? Some scholars think that the word three, in most languages, used to mean too much. Long ago, man counted up to 2, no further.
What a blessed time it was!
This is using. But take 9,527,364,180. It takes just 10 seconds to write down, and this figure is more than the number of people on Earth. Numbers are the vast portion. It's fascinating to stay on it.
Five, 6, 7, 8, 9. What a boring seat, Captain.
Boy, didn't you see the 0? Of course you missed it. Let me tell you that this one makes this seat much more interesting. Without it, we wouldn't be able to say we are heading to number 10.
10, yes, Captain, you're right. We are heading to number 10. And I can see indeed a 0 in this number. A quantity of 10 and nothing more. 0, nada. But already I see that we're approaching 11, 12, 13. I think I'm getting bored again.
12 and 13, you said? These are two very different points of this motion.
What do you mean?
12 can be nicely divided. You can say it's 3 times 4, 4 times 3, 6 times 2. Whereas 13 remains 13. It's a prime number. It's not boring at all if you take time to look around you.
You're right. It's not at all boring, in fact.
You know, boy, on this sea, the only limit is our imagination.
Captain, I can see a ship to starboard.
I'm Euclid. I've been sailing tirelessly on this ocean. They inspired me 13 books. I even sailed beyond this sea of numbers on a sea of shapes, of perfect shapes. Some of them were endless.
Mr. Euclid, the ocean of numbers and the ocean of shapes, are they connected?
Yes, they are. Numbers measure shapes. The numbers measuring the same shape are linked to each other.
Could you give an example to this young boy, Mr. Euclid?
Yes. For instance, the perimeter of a circle is always about 3.14 times as long as its diameter. And by prime numbers, I have been able to prove by a clever reasoning of mine that there is an infinity of them.
Thank you, Mr. Euclid. Goodbye.
Goodbye.
You see, boy, if you get bored again, you can still try to fish prime numbers, since there is an infinity.
Okay. I just got one, Captain. It's 15.
Dummy, 15 is not a prime. It's 3 times 5. Put it back to the sea.
Oh. Sorry, sir. I put many this time. 17, 19, 23, 29, 31.
Great! It looks like you're now a good fisherman. Enjoy, boy!
What is that?
Oh! It's not a prime, but an equation. We are now sailing on the ocean of partial differential equations.
Second degree equation.
Second degree equations, sorry.
That's right. And this equation has exactly two solutions, which are 3 and 7.
Who are you, sir?
I come from the 9th century, all the way from Baghdad. My name is Algebra. I've written a book called Algebra, in which I explain what is an equation and how to solve many of them.
I see that 7 is a solution because 7 squared minus 10 times 7 plus 21 equals 0.
Very good. I see you can check that a number is a solution.
But to find out which numbers are solution when you have no clue at all is a more difficult task that I can do.
But I'm sure you will soon be able to do it.
I must be going. Enjoy your journey.
Bye, Mr. Algebra. These mathematical oceans we're sailing on, are they connected to the real world, Captain?
Of course they are. Reality is sometimes a harbor from which the journey starts.
Captain, I need an example.
Okay, boy. We are heading for ocean of partial differential equations. Hurry up!
This region looks so strange. I wonder what this equation means, and which numbers are its solutions.
Solutions are not numbers, but functions.
But, Captain, you told me that you would show me an example coming from the real world.
I told you the truth, boy. I'm your captain, remember. These equations are all about waves, like waves propagating on the surface of the water, like waves created by my vocal cords when I talk to you.
Do you mean that waves can be put into equations?
Yes, because a wave propagates in a specific way. The equation expresses the way the wave propagates.
But the solution to this equation, what is it then?
It's the wave itself, or more accurately, the function that allows you to know everything about the wave in any place at any time. Like the function that tell you how high will be the wave here if you throw a stone over there a minute before.
I think I'm not a good enough sailor yet to sail on these seas, Captain. I feel a bit dizzy.
It's just normal. Don't worry, you have to learn. But if you come to like it, you will come back, and I'm sure you will succeed. You see, when you glance at an equation like this one, you see that each symbol is important.
If you remove one, it's all nonsense. It seems that the perfection can be reached not when nothing can be added, but when nothing can be taken away. In this equation, nothing can be taken away.
Well said, sir. It's just beautiful to hear you talk.
Thank you, boy. I confess I quote Antoine de Saint-Exupéry in Terre des Hommes. He was not talking about math equations, but about planes.
What a strange dream. Where did I learn all this?
We will come back, and we will attack many of these equations.
Congratulations.